So I think we're live. My last stream got cut off by about an hour or so. It was supposed to be 2 hours, but it's 1 hour, and there's some sort of issue at the end of the video. But I'll just give a small recap of where I what I've done in the last stream. First of all, I refactored the code to more idiomatic code, I guess, because the first time scratch pad L. The first time I wrote code for the program, it was a bit like writing C in Go syntax. But now I'm using like this. I'm using strings, and I'm just following whatever the tutorial was saying. Like they wanted me to uh, create a string to hold the contents of the current line, then split the data on new lines, and then skipping the last part. I got to know why we're skipping the last part, because split method, if you have a backslash n at the end of uh, a string, then the last element of split is an empty string, and otherwise it's the last part of the string. I don't want to go over it again, and I'll just continue from here on onwards. Now the part 5 is saying, this is the code for anyone who wants to read it. They can pause it and read it. Okay, so channel refactor, and I was reading about Goroutines and channels. So Goroutines are basically coroutines, but they also handle multi-threading as well under the hood. So you have multiple coroutines and you have multiple threads, and Go is managing all of them. Let me just explain the difference first between async. I also did this in the last team, but anyways, let's just do it again. So say you have let me first explain what multi-threading is. um, yep. See. Hmm. So these are OS level threads. Say you have a program with 3 threads. In it, basically, you have one thread running on one hardware thread, or you could just say one processing unit, because nowadays processors also have like more than one thread. But let's just say one processing unit that takes in instructions and executes them, and you have another thread that's running on another hardware thread or processing unit, and you have another thread that's running on another hardware processing unit, and these 3 threads belong to the same program. For now, just assume that they are handling different TCP connections. So this is handling client 1, this is handling client 2, and this is handling client 3. When the client is not sending any request, it is just this thread is just busy waiting. It's just wasting time and CPU cycles. And when this thread doesn't have anything from the user, it's just wasting cycles. And when it does get an input from the user, it responds appropriately. and so on. These three sets share some data and some code, but essentially they have different stack and heap memory, and they are working independently, and they are working in parallel. This is parallelism. This is useful in cases of you have a large number of independent, you have like three independent tasks, and instead of executing them one by one, you execute them in parallel. And if you want to share data between them, you have to use synchronization primitives like mutexes, etc. Then you have the concept of coroutines, not go routines, coroutines. In a coroutine is basically in a single thread. It is the concept of coroutines is the same as the concept of like async functions. If you know a little bit of JavaScript. So basically, you have a multiple functions that switch context between each other, which execute in, you could say, in turns. So the function 1 executes a little bit, then it saves its context, and then the function 2 executes a little bit, it saves its context, and then function 3 executes a little bit. This is useful in cases where in networking applications where you have a thread, where you have multiple suppose TCP connections, and you want to be able to handle a lot of them, and you don't want to waste CPU cycles in busy waiting. Like if a client is not sending any data, the coroutine managing that client goes to sleep, and then the other coroutine, another coroutine gets the CPU allocated for it, and it handles a client. When it's done handling a client, it goes to sleep, and then another client gets handled, and so on. So it's basically like CPU scheduling, but on the user level. It's kind of like that. So coroutines are useful because of two things. One, because you can have a large number of coroutines, and number two is that CPU cycles are not wasted. And this is useful particularly and maybe only in cases where you have a large amount of waiting for IO. Like if some procedure is waiting for IO, it can just wait for IO, and yeah. And if a coroutine is, say, sleeping, it will only be awakened when how should I say this? The coroutine will only be awakened when there is something written to the socket, like in case of network apps. So there are two ways of coroutines to hmm, uh, let me rephrase. Say when coroutine 1 wants to read from the socket, but there is nothing available on the socket, so it yields. It goes to sleep, and then what happens next is coroutine 2 starts executing, and when coroutine 2 uh, handles its client, it yields, and upon yielding, two things happen. The first thing that happens is that the coroutine scheduler checks whether or not uh, the coroutine 1, the socket on which coroutine 1 was listening, has had any update to it, has had any data appended to it. If it has, then coroutine 1 gets the scheduler wakes up the coroutine 1 and puts it in the ready queue, and then there is some sort of scheduling algorithm on the basis of which a coroutine is selected, and it starts executing. And yeah, that's it. And when every coroutine yields, some data is supposed to be saved, and each coroutine has its own sort of stack so that its local variables are separate from the local variables of others, and when it yields, the stack and the registers of the coroutine are saved, and when it gets entered into execution, the stack is loaded, the RSP is set to the stack of the coroutine. RSP is, the stack pointer. This is an assembly concept, and the registers get loaded with values that were the last time the coroutine was executed. But in Golang, the scheduler not only handles coroutines, it also handles multiple threads and the synchronization between multiple threads. So you can have like 7 coroutines alternating on this thread, and you can have like 6 coroutines alternating on this thread. And if one coroutine needs to communicate to the other coroutine, only need to think in terms of goroutines and channels. And it's a great abstraction because you don't have to think about multi-threading issues. And I was reading this article, and I'm gonna finish reading this article now. uh, okay. um, you don't need complex executors, you need your third-party libraries. Primitives are built in the language and no time. Blah 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 blah. You don't architect around a thread model, you architect around logical concurrency. Hmm. Yep. And I'm gonna be eating as well while I'm working because I don't have much time to. I have a busy day today, so yeah. Hmm. So I'll be speaking less. I'm already tired of speaking for like 2 hours in the morning. But the sad thing is that 1 hour of all of that got deleted. Okay, so there's something also known as a weight group, and there's okay, okay. Hmm. Okay. Yes, they aren't always predictable in execution timing. I ran some code the last time and it didn't work as I was expecting. Actually, I can run that again. Go run go routines. Yup. Mm, I don't want to explain it. I explained it in depth last time. The last time. Uh, okay, okay. Yup, yup, yup. The learning curve is flat. Okay. What is CSP? Style guarantee. Actor based concurrency. What's actor based concurrency? Okay, Goroutines leaking is actually not uh, a big problem if it's not leaking much because it won't hurt your performance. Unless it doesn't hurt your performance, like leaking isn't that much of an issue. Unless like you're leaking again and again and a lot, then it can hurt your performance. Maybe the stack of the Go routine is super big, like some megabytes, then maybe. I don't know. But we have like gigabytes of RAM nowadays, so it shouldn't be a problem. Yeah, it will be if like you leak again and again, or and over time it will cause issues for like long running programs. Same, they are manageable downside, productivity, blah 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 blah. Context cancellation, select statements. Okay. Okay. Hmm. Okay. Hmm. Okay. 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 What's this? Okay, so you can like send a few values. Okay, so it won't block until the. We can test this. So what's the difference between a buffered channel and an unbuffered channel? How do you make a channel buffered? Okay. So you okay. Okay. So what I want is I want to import time and I want to go like time dot sleep time dot second. I think it's like this. Uh, and um, yep. Yes. So basically, it the channel blocked. This thing was blocked. Sorry. Let me think of one thing. Uh, yeah, this is what I want. I sent it. Okay. And what I want to see is whether or not I sent it immediately or I get it after 5 seconds when you have a receiver. Since this channel is unbuffered, the this print ln will only get executed after 5 seconds. Yep, it did. And now when we go and say that our channel is buffered and has a buff size of 1, then it sends and moves on. Amazing. And if you have like a 2 size buffer, no, let's just keep it size 1, and then this should be like 2 seconds. 5 is too much. And send it and pong. And what I want to show is this send will not take any time, but this send will take 4 seconds. Yeah. And if I comment this out, it'll take forever. I can show it. No. I think I made a mistake. If I comment, yep. Now Since there is no receiver, I send it again will never run. And we will have an infinite loop. On mismatched types, Jan string and untyped string. What? Okay, I got it. The problem is we don't have a hyphen. And now we are stuck in an infinite. What? Oh, I got it. So what's happening is the this guy sends, and then the buffer is full, and then this guy waits 2 seconds and then it receives. The buffer is now empty, and then Pong gets the message. Okay. Now we'll be stuck in an infinite loop. What is happening, bro? So it drops the values. Okay. Then why did they say that channels block until the sender and receiver are ready? So what happened was that this guy did something, and then maybe the program exited. Yeah, so if there isn't a receiver, it just fails and exits the program, I guess. Yeah, I'll just send this time in like 5-10 minutes. My eyes are closing. Maybe we'll look at this later why the code isn't working. So we do block if there exists both the sender and the receiver. Okay, so what we can do is if a sender and receiver both exist, then the thing will be blocked. Oh my god, come on, bro. And then you do this guy. And so it sent it. Now it okay, so it sent it because of the buffer. If you don't have a buffer, Okay, yeah, everything. Why didn't I send it run? I don't know, man. Okay, so these guys don't run. Okay, okay, I got it. We now know what go routines are, what channels are, how they work. And now we know what buffered channels are. And now we know like channel synchronization. Okay. Uh, uh, um, there's a lot of stuff, but I think we have enough. Like we need a channel. What's this? I don't know, man. And what's this IO dot read closer? I'm just ending the stream. I want to sleep.